A pleasant greetings to all. In this video, I am going to explain what is mean by block diagram and what are the reduction rules used in the block diagram. What is block diagram? A control system may consist of a number of components. To show the functions performed by each component in control engineering is represented by a diagram is known as block diagram. A block diagram of a system is a pictorial representation of the functions performed by each component and of the flow of the signal. Next, rules in block diagram reduction. Rule number 1. Two blocks are connected in series. One of the block is G1, the next block G2. The signal, that is input signal X1, output signal X2. So in this point, what about the value of the output X1 into G1? Now what is the value of the signal X2? X1 into G1 into G2. So two blocks are connected in series. The resultant block is multiplication of two blocks G1, G2. Next, rule number 2. Two blocks are connected in parallel. Here X1, G2. Here X1, G1. What is X2? Addition of both the signals X1, G1 plus or minus X1, G2. Take X1 common, G1 plus or minus G2. When two blocks are connected in parallel, what is the resultant block? Is a summation of both the blocks. Rule number 3. Moving a summing point after a block. This is the summing point. Have to move the summing point after a block. So this is the resultant block diagram. Now the summing point is moved after a block. Now I have to find out the output signal. Here X1 and X2. What is the resultant here in this point? X1 plus or minus X2. Now this is multiplied with G. We'll get G into X1 plus or minus X2. So this is the equivalent block. How it is obtained? Multiply the same signal G, same block G in the signal X2. So X1 into G, here X2 into G. So what is the resultant value? G of X1 plus or minus X2. Rule 4. Moving a summing point before a block. So this is the movement. And what we have to do? We have to multiply 1 by G with the signal X2. Here X1 into G and here X2. So X1 into G plus or minus X2. This is the resultant value. Here this is X1 plus or minus X2 by G. Now the total value is multiplied with the block G. So X1 into G plus or minus X2. So both the resultant values are correct. Rule 5. Moving a takeoff point after a block. After a block. So this is the takeoff point. What we have to do? Have to multiply 1 by G with the signal X1. See X1 into G. This is the resultant block diagram. X1 into G. This X1 into G. That is multiplied with 1 by G. Again we get X1. What is rule number 6? Moving a takeoff point before a block. See, the signal X1 is multiplied with G. Here x1 into g, the same x1 into g. Here x1, x1 into g, the g. Here also x1 into g. Rule 7. Eliminating a feedback loop. What is feedback loop? Output is connected to the input. That is known as feedback. Here x1 and H is the feedback block, G is the forward block. x1 plus or minus H into x2. This is given to G. So what is the resultant value here? G into x1 plus or minus H into x2. Now G x1 plus or minus H x2, that is equal to x2. Both are equal. Have to expand this. G into x1 plus or minus GH into x2, that is equal to x2. Next, G into x1, that is equal to x2 minus or plus GH into x2. So Gx1 equal to, take x2 outside, 1 minus or plus GH. So what is x2 by x1? This is the transfer function. That is G divided by 1 minus or plus GH. For example, we have to use the positive feedback loop, means the answer may be negative. Positive feedback loop is, answer is 1G by 1 minus GH. For example, if you use a negative feedback loop, means what is the answer? G by 1 plus GH. Rule 8. Interchanging summing point. See, x1 and x2 is connected in this point. So x1 plus or minus x2, that is given to the next summing block, and the third signal is x3. These three are combined together. Have to interchange x2 and x3 only. x2 is connected plus or minus value. x3 also connected, same plus or minus. Just I have to interchange this. Instead of x2 I have to use x3, and instead of x3 I have to use x2. So this is the resultant block. Rule 9. Splitting the summing point. See, this summing point consists of three signals, x1, then x2 and x3. Three are combined together and we will get x1 plus or minus x2 plus or minus x3. So I have to divide the summing block into two. So one of the block consists of x1 and x2 only, and the resultant is connected with x3 block, will get a final value. So in this way, first I have to use x1 and x2. So we'll get x1 plus or minus x2. Then again it is added with x3. So x1 plus or minus x2 plus or minus x3. Next I am going to explain a problem in block diagram reduction. Obtain the transfer function of the control system whose block diagram is shown in figure by block diagram reduction technique and by signal flow graph method. So in this given block diagram, the output is C and input is R, three summing points 1, 2 and 3. Now I am going to explain how to reduce the block diagram and how to convert this block diagram into a single block. In this diagram, first of all, I am going to apply the rule number 2. Two blocks are connected in parallel. G2 and G3, both the blocks are connected in parallel. So what is the resultant block? Resultant block is G2 minus G3. And next G1, G2 minus G3, These two blocks are connected in cascade or series. So multiply both the blocks, G1 into G2 minus G3. And next, here the summing point, have to move the summing point after a block, then only I can solve the problem easily. So I have to move the summing point after the block. So what I have to do? Have to multiply H2 with the signal R. So I have to multiply H2. And next, H1 and H2 both are connected in series. G4 and H2 both are connected in series. Multiply H1 and H2, and here multiply G4 and H2. And next, have to interchange the summing points. So see, G4 H2 signal is connected to the negative terminal. The same is connected to the negative terminal. So minus into minus, that is positive. So I have to connect the summing point here. Here the gain 1. This is connected to the positive of the summing point. And next it is connected to the next summing point. Here H1 and H2. This is connected to the positive terminal. Again it is connected to the negative terminal. So positive and negative, that will give the value negative. So H1 and H2 is connected to the negative terminal of the second summing point. How to reduce this? See the first one, here 1. Both are connected in G4H2 and 1 both are connected in parallel. So I can write like this, 1 plus G4H2. And see the next part is the reduction of negative feedback loop. So what is the formula? G divided by 1 plus GH. Instead of G, we are having G1 into G2 minus G3, and instead of H, we are having H1 into H2. Have to substitute here. So instead of G, you have to put G1 into G2 minus G3. So 1 plus G1 into G2 minus G3 into H1 into H2. Next, redraw it. The block number 1, 1 plus G4 H2. Block 2, G1 into G2 minus G3 divided by 1 plus H1 H2 G1 into G2 minus G3. Here both the blocks are connected in series. What is the resultant block? Multiplication of both the blocks. 1 plus G4 H2 is multiplied with G1 G2 minus G1 G3 divided by 1 plus H1 H2 G1 G2 minus H1 H2 G1 G3. So you have to expand the numerator terms. So G1 G2 minus G1 G3, then the same term is multiplied with G4 H2. So G1 G2 G4 H2 minus G1 G3 G4 H2. So whole divided by 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. This is the transfer function of the given block diagram. Next, I am going to explain how to draw the signal flow graph from the block diagram and how to find the transfer function from the signal flow graph. See, this is a block diagram. First of all, I have to mark nodes instead of takeoff point and summing point. Here mark the nodes here, node, here also in the summing point node, and here also you have to mark node and then naming the node 1, 2, 3, 4, 5 and 6. Okay, I have to naming the node 1, 2, 3, 4, 5, then 6. See, between node number 1 and 2 there is no gain, so put 1. Between 2 and 3 the gain is G1. Between 3 and 4, the gain is G2. 4 and 5, there is no gain, so take 1. From 3 and 4, that is the gain minus G3 because G3 is connected to the negative terminal of the summing point. And 1 to here 5 and 6. Between 5 and 6, H1. That is positive H1. And from 6 between 6 to 2, 6 and 2, the H2 is there but is connected to the negative terminal of the summing point. So minus H2. Between 6 and 1, that is G4 is connected to the negative terminal. So minus G4. In this way, have to draw the signal flow graph. After finishing the signal flow graph, have to find out the transfer function. Have to write the formula for transfer function, that is summation k is equal to 1 to n pk delta k divided by delta. Pk is the forward path gain, delta is the same as delta, that is not touching the loops, not touching the kth forward path. So what is delta? Delta is equal to 1 minus sum of individual loop gain plus sum of gain product of 2 non-touching loop minus sum of gain product of 3 non-touching loop and so on. So from this block diagram, first of all have to mark the number of forward blocks. Okay. So this is the first forward path. And this is the second forward path. And next, this is the third forward path. Third forward path. And next, this is the fourth forward path. So all the forward paths are over. So what is forward path? Forward path is the signal starting from the input and ends at the output, that is known as forward path. Okay, forward path number 1. So first of all, have to write the first forward path. So first forward path P1. So what is P1? P1 equal to G1, G2. And next write second forward path P2. P2 is G1 minus G3. Minus G1, G3. And what is the third forward path? Third forward path is minus G4 minus H2, G1, G2. So P3 equal to G4, H2, G1, G2. P4 equal to G4, H2, G1, G3. So minus G4, H2, G1, G3. So forward path is over. So after finishing the forward path, find out the number of loops. So number of loops are, the first one, loop number 1. So loop number 1. What is the loop number 1? Have to mark the loop number 1. So first loop is starting from the input and ends at the same input, that is known as loop. Okay, here how many loops are there? The loops here is, there are 2 numbers of loops are there. Here the starting at the input and ends at the same input, loop number 1. That is G1, G2, G1, G2, H1, H2. G1, G2, H1, H2. Okay, and the next loop is G1 minus G3 H1 H2. That is also a next loop. So next I have to mark the next loop G1, G3, the same H1 H2. So this is the loop number 2. So I have to write the loop number 2. So loop number 2 is, once again I have to write loop number 2 is equal to G1 minus G1 G3 H1 H2. So this is the loop number 2. After finishing this loop number 1 and 2, what I have to do, I have to apply this in the transfer function formula. So what is the transfer function? P1 delta 1, P2 delta 2, then P3 delta 3 plus P4 delta 4 divided by 1 minus loop 1, loop 2 and so on. Okay, here what is P1? G1, G2. What is delta 1? That is all the loops are touching in this forward path. So 1 plus P2. What is P2? P2 is minus G1, G3. And what is P3? P3 is a forward path. G4 H2, G1, G2, G4 H2. And next one is G1 minus G1, G3, G4 H2. So all are over. Here all the loops are touching in the kth forward path. Here we are having two loops. Loop number 1 is G1, G2, H1, H2. Loop number 2 is minus G1, G3, H1, H2. And here I have to write 1 minus minus G1, G2, H1, H2. Here minus into minus plus G1, G3, H1, H2. That's all. Thank you. Have a nice day.